This conference will now be recorded.
Okay, so all right. So thanks everybody for joining, and myself, Harkishan. I have more than 13 years of experience, development experience in Java JDE technologies. I am currently working as a solution architect, where I'll be working closely with the customers and technical team and the executive team to propose the solution. And from last 2 years, I've been working on the AWS deployment. So, and also I am a certified associate architect and developer, and I am also in the process of getting professional level certification. And this, as part of this, today I will try to cover VPC, some fundamentals, and also we will see how we can bring up a VPC. We will talk about that. And as you know, we have covered the basic fundamentals in the previous session. What is EC2? We tried to spend 3 sessions on EC2, and also we talked about IAM. So IAM and EC2 and VPC, these are the three core and fundamental AWS services. On top, the remaining services are built with. Let's say an example, ECS, you take ECS or EKS, basically they will be internally using EC2 service to provide those containerized services. So that's the reason I am putting more stress on talking about EC2 and VPC more, because the more fundamentals you understand, the easier for you to pick up the other services that are available in AWS. And also, the more time you put understanding these basics, the less time you spend in troubleshooting the actual problems when you are using them. So, having said that, let me start with the agenda today. So, this is about VPC, that means a virtual private cloud, which means we will be setting up our own network to deploy our applications and software, which means starting from provisioning the network and then the missions, everything we will be doing end to end, which means we will have to have some basic terminology understanding of network, which I will try to cover, and then I will go to what is VPC. Then we will talk about some use cases, on which use cases we can use it VPC. Then I will also discuss some elements of VPC. Then we will also see some default VPC we will be getting automatically when we create a AWS account that we will talk about. Then I will talk about some planning. Say we will be creating our own VPC that I will try to cover within the session itself, where we will plan how we can plan the IP addresses, CIDR, and then how we can plan our subnet, all those stuff. So having said that, let me start with the network terminology first. So if you look at the network, basically a subnet, this is mostly used terminology when we talk about VPC in this session and the next 2-3 sessions. And also this is very important for you to have this terminology very clear for your day-to-day work as well, if you are dealing with AWS deployment or any troubleshooting. So basically a subnet is used for divide your network. It could be your corporate network or any other small network you have, which can be subdivided into smaller networks, so that you can have a isolated environment created for you. So if you look at your corporate itself, for deploying any applications, your business applications, they will be creating subnets in it, and then they will be allocating IP addresses to that subnet. So as you see in the diagram before, you see there are any IP address we take, which will be having two parts. One, the first part will be used to identify the network, and the second part, which is shown in the yellow here, is basically identify the host in it. So basically, if you have a network which is say capable of having 256 IP addresses, and then further you can divide that into smaller networks using this subnet. So basically, this within that you will have your network identifier as it is unchanged, but within the host identifier itself, you will be dividing them into multiple subnets. So that is what the subnet is for. We will be using a lot in this session and future sessions related to VPC. And then we just need to understand different classes we have in IP addresses. And those who are not from IT background may be new to you, but I'm sure we would have studied these IP classes in our like graduation or when we are doing our computer science course or thing. But yeah, this is how the IP address classes are. Basically, we have class A, class B, class C, and class D, which you can see in the table here. Basically, that is classified based on the first three bits that it has. Like for class A, the first one bit is 0, and then for class B it will be 10, and class C it is 110, and for class B it is 1210. So based on that, there are some examples also given. Usually you see in your corporate network, if you look at your IP address when you go into the office, sometime you might mostly will be seeing like 10 dot some IP address you will be seeing it, and whereas in your private network you see 192.168. This is for smaller network, and this is something for medium-sized network. So this is how the IP address classes are defined. But I mean, for now, just have understanding that we have different classes of IP addresses and which is used for what. Like type A will be mostly used for corporate, and type C will be using in your home network. That means a smaller network. And D is very rarely used, and it is not actually used for any use cases, but this is mostly for a single computer, mostly used for monitoring or some network administration purpose. We use this type D class, right? So going to the next terminology, we have a problem with IP address classes. I mean, traditionally we have this type A, B, C, and D, but the problem with that is like as you know, like to get a license for any network, you will have to pay to the Internet Authority, so where you will be assigned with a particular network number. So for, as you know, like type A, class A address license is costly, and then class B is cheaper than class A, and then class C is even it's mainly used for private address, so you cannot be paying also. But let's imagine a company which is a medium-sized company, so they want to get a class B license, which they get only 254 host machines they can address within their network, within the assigned network. But they want to use it like, say they have a little bit more than 254 host machines they want to use it in their network. But for that, they have to go for a class A license for that network, which will give you like 65,000 or 534 host machines, but they won't be using at all. So this is actually, there are two problems. One is that the company itself is, let me mute everybody. So, okay. Yeah, so feel free to send a message in case you have any question or anything. I see there are questions. Okay, so feel free to text me in case you have any question. But yeah, so this is the problem. Number one will be like the company itself will end up paying extra money for Class A license. And the second thing is they will not be using all 65,000 IP addresses. So to solve this problem, we have a new or it's now already being used by many people that is called a CIDR, that is classless interdomain routing. So where they can there is no class level licensing, but rather we can get the licensing fee based on the CIDR block. I mean, let's say you want only say 500 addresses, you can purchase a smaller block, CIDR block. So like that, you will not be ending up spending a lot of money. Plus, you will be purchasing only the number of IP addresses you need. I mean, it will exactly match your business needs, right? So typically, the CIDR block is represented like this, as I shown in the example, and IP address /18. The 18 actually represents the network part, and the remaining bits will actually represent the host addresses. So in this way, you can purchase CIDR block so that you will get only the required number of IP addresses you need for your business, right? So this is some basic terminology you need to understand, because these things we will be talking a lot for the rest of the session. Having said that, let me jump directly into the VPC. What is VPC? Is a virtual private cloud from Amazon, which lets you to define your own logically isolated network within the cloud itself. So, I mean, for any application deployment, traditionally also, we usually have a separate network created for application deployment. Similarly, in the cloud, if we want to deploy any of our applications, like a simple web application or a enterprise application, we can define our own isolated private network using this VPC. So this will and also using this, one more benefit with the VPC is traditionally when you create your on-premise data center network using subnets, for any scaling or other features, you'll have to implement additional set of tools like Kubernetes, or if the application is like containerized, you'll have to define additional tools integrated so that it will scale the application as the load on the application increases. But with the VPC, you can define your network using the subnet planning, and also this VPC can make use of all the auto scaling capabilities or functionality available in Amazon automatically. So you need not to do an additional tool integration to your network. So basically, VPC is, I'm repeating, it will help you to create your own isolated network within the cloud, and plus it can also leverage the auto scaling functionalities available in the AWS. Right. So let me talk about some use cases where VPC can be applied. VPC can be used like to host a simple website where you can, so let's say there is no static website you're trying to host it. So simply you can create a VPC and then you can add a subnet in it, which is a public subnet, and then you can create your EC2 instance in it and start your web service. And the use case 2 would be you can also deploy your entire web application. When I say entire web application, it would be like a 3-tier web application where you have your front end or HTML UI in one tier, and your model or a business logic will be in another tier, and then you have a third tier called a data, where your database server or database software is installed. So that is called a 3-tier architecture. So you can use the VPC for implementing an entire application also, where you will be defining two subnets. One is a public subnet where you will be deploying your front-end user-facing application, web application in public subnet, and then you will have a second subnet which is private, where nobody will have access to it, and where you will deploy your business logic layer and your database layer in the private subnet, right? So in this way, your application is fully secured and it is isolated from other EC2 instances or other AWS resources. And also, in addition, the VPC will provide an additional monitoring capabilities. You can watch the packet monitoring, and the CloudWatch also some metrics to monitor your VPC. So you can also make use of those additional tool functionality to monitor your VPC as well. So this is the very common use cases, like I said, a simple website and entire website. And most of the people, what we are working on day to day is entire web application where you will have a UI and a backend. So that will be covered with this use case itself. But there could be another use case, like I mentioned before. You need to deploy a scalable application because you do not know the actual load on the server that is going to be, like, say you are deploying a retail website where the number of customers are going to be huge on a typical sale day or a Thanksgiving day or sometime, where the number of subscribers visiting your website will be multiplied by 100 times or 200 times. And also sometimes in the weekends, you get a lot of load on the subscribers. Basically, on the weekend, people have time to do a online shopping where you see a lot of customers visiting your site. But on the weekends, on the weekdays, you have a normal load. So that is where this auto scaling comes into picture, where it will provision the number of servers required based on the actual load that is available in the system on the application. So what you can do is, like I mentioned, you can deploy your application on the VPC, then and also you will provision in your EC2 instances using an auto scaling group. So auto scaling group, something I will cover maybe in future sessions. But for now, you can just think like you need not to worry about deploying or spinning up new instances if there is a sudden spike in the system load, right? And then you have some other variety of application. Use case number 4, where you see, I would say it's an hybrid application deployment, where you have your front end deployed in the cloud, but your backend is deployed in your corporate network, which means due to some security reasons or Oracle licensing purpose, you cannot deploy your Oracle database server in the cloud. So this is a very common use case where you cannot simply migrate your Oracle software into the cloud, because some customers may be purchasing the license for, say, next 10 years. So until that license expires, you have to ensure that Oracle server is deployed in the on-premise. I mean, there will be some license exist like that. So for that purpose, let's say you have your database server exist in your on-premise corporate network. So you can connect them with a secure tunnel, IPsec tunnel, and have your only front end deployed in cloud and your back end deployed in the corporate network. That is also possible with the VPC. And there could be another variety where you can extend your corporate network. Sometimes you want to scale your functionality, like let's say you have your corporate emailing or your corporate storage, like OneDrive, like what we have today, like OneDrive, where every employee gets some amount of storage where they can store the files. That is nothing but a cloud storage. You can provide something like that, cloud storage. You can start with say 1 TB per employee, but depending on the need, say some of the employers need like 2 TB or 3 TB of storage, you can always extend that storage in the cloud if you migrate your file server kind of applications to cloud, right? Then we can also use the VPC as a disaster recovery, where you can regularly push your data, very important data, into cloud. That means you will be pushing your all important data into cloud, so that in case for some reason your corporate data center goes down, you can recover the data back from the cloud. So for that, typically what people do is they create a VPC in the AWS, then they provision a EC2 instance, and they attach some volumes, EBS volumes, and then they periodically push the important data to this EBC volume, so that this volume is secure. Even in the case of a crash or a disaster, they always can recover the data from the cloud. So these are the some use cases, but these are not limited. You can have your own use case, but most of the time your need will fall under one of these categories if you think of these use cases in a broader sense. Right. So going to the next slide, this is a typical VPC block diagram looks like. As you see, a very outer layer box, VPC will be per region. Like say if you have created your account, by default you will be assigned with a region. So within that region, you can have any number of VPCs. But again, the number of VPCs, there is a limitation. You'll have to check in your account. Like if your free account, there is a limitation. If it is a corporate account, there will be a number of VPCs allowed. So it is always better to check for your account how many VPCs you can create per region, and that is also documented on the Amazon site as well. But the main point here I'm trying to communicate here is, whenever you create a VPC that belongs to a particular region, and within that VPC you will have the VPC typically associated with the CIDR block, which I covered in the beginning. CIDR block is basically, it gives you a set of IP addresses for your VPC. Those IP addresses will be used or assigned for your instances, EC2 instances that will be defined inside your VPC. So yeah, so the VPC will have a CIDR block. Then inside that, you will be creating subnets, because once you have your big bunch of IP addresses, you will be separating them, like logically separating them into multiple subnets, so that you can manage your application deployment in a clean fashion. As you can see in this diagram, there are two subnets created within the VPC. One is called a public subnet, where you can place all your end user facing applications in that. As you can see in the public subnet, I see a web server is placed there. And as you can see, there are 3 web servers there, which means they would have done some auto scaling also defined within that. That indicates that the auto scaling is also defined. Or you can have a static list of 3 instances you can provision there, and you can put them all 3 instances there, right? And as it says, it's a public subnet. That means it can access internet, and outside people also can access these web servers directly. But on the other side, you see a private subnet, where before going to the private subnet, you can see the public subnet. There is a IPDR block defined for that, which means within the bigger block, as you see on the VPC here, what I'm showing, there is a IPDR block is there. Within that, again, they are splitting into 2 separate blocks, CIDR blocks, that is 10.00.24 and 10.00.10.24, which means within this big piece, again, we are separating them into 2 subsets, right? That is what we have actually covered in the very beginning of this session. And then we have a private subnet, where we will be placing all our business logic and database servers, which do not need any public access. So we can place it here. Then we have internet gateway, which is for every VPC, we should have an internet gateway attached to it, which I have those definitions in the next slide. Then we have a router. Router basically tells all the routing rules for each subnet. Every subnet will have one route table attached to it, so that all the routing information, any internet traffic goes out, in and out, that will have goes through this particular router. So we'll have to have a routing table attached to it. So that is all the mandatory components for creating a VPC here. And if it is not making sense, just bear for some more time, because we will be creating the VPC from my account, so you get some idea about it. And going to the next slide, I'm trying to document the basic elements, what we have in VPC and what we can use with the VPC. Like I mentioned, Internet Gateway. Internet Gateway is required for all the traffic that goes to Internet, or any traffic which is coming from the Internet to your VPC. So every VPC must have one Internet Gateway attached to it. We will show you how it can be created and attached to it. And NAT gateway is another component which will provide, as you can see here, I see a NAT gateway here. The primary purpose of the NAT gateway is, suppose my database server requires a patch which is available in the Oracle site or public internet. So to apply the patch in my database server, I need to have some internet access. So to provide that, there is a concept called a NAT gateway, using which once I create a NAT gateway and attach to this private subnet, then all my servers which are available in my private subnet, which they do not have internet access, they can get the access to the internet and apply the patches. So NAT gateway primarily used for that purpose. So networker is used to enable instances in a private subnet to connect to the internet or other AWS services, right? But the inbound traffic will not be allowed with the NAT gateway, right? So route table, basically route table contains a set of rules. It will help you to route the traffic between the subnets and also the subnet which goes to outside. So all that routing logic will be encapsulated in the route table, and usually every subnet will have one route table, but multiple subnets can also use the same route table. That we will cover in the lab we will be doing. Then we have ACL. ACL is nothing but network access control list. This is a kind of a firewall, you can think, where usually you see in the Linux firewall or Windows firewall, you will be listing a particular IP address, and then you say a particular port, then you say either allow or deny the access. This is also same, where you will be specifying a particular block, CADR block, or a particular IP address, then a port, then you will say whether allow the traffic or deny the traffic. So you can think ACL as a firewall, and this is also you can use with your VPC to provide more security to your resources that are deployed in your VPC. Okay. So going to the next slide, there are some other additional features available in the VPC which are optional, but mostly you will be using this functionality as well, because when you work with a real-time solution or an application, you will some other time you may need to understand these concepts and you will be using it. So egress only internet gateway is also same like an internet gateway, but it is mostly used for IPv6. So if your application requires IPv6 communication, you will have to use this egress only internet gateway, and this gateway cannot be used if your subnet is like using IPv4 addresses. You cannot use that, but if your subnet is using IPv6 based EC2 missions, then you will have to use this egress-only internet gateway. Then we have a classic link. Classic link will help you to link a traditional old model EC2 instance wants access to your VPC. Say a EC2 instance, a virtual machine which is outside of your VPC wants to talk to another another EC2 instance defined inside the VPC. For that, you can use a classic link to define a link between the external EC2 instance and the internal EC2 instance. This is another way of providing the access and secured access, so that the other instance, which is the internal instance, EC2 instance, need not to have a public IP address. Then we have a VPC endpoint. VPC endpoint basically used to connect to other VPC endpoints. Sometimes when you create your VPC and you want to expose some of the functionality of your VPC to other VPCs, you will be creating an endpoint to your VPC, so that using that endpoint, other VPCs will be connecting to your VPC. So endpoint is, you can think like you're writing an API and you're providing an API interface. Similarly, this VPC endpoint will also expose an endpoint interface using which other VPCs can connect to you. And also using this VPC, you can leverage some other services which are available in the VPC that I will cover, basically like EBS or a S3, all that kind of services also you can access using this. And then we have a VPC pairing. VPC pairing, you can have two VPCs talk to each other. So the routing between those VPCs exactly acts like as if they are present in the same VPC. It is like you're establishing a network connection between two VPCs. So VPCs pairing can be done to one-to-one. There is no transitive. Let's say you have three VPCs defined, VPC A and VPC B and VPC C. So to make A and C to talk, you have to have a direct VPC pairing between VPC A and VPC C. Similarly, if you want to talk to B and C, you have to have a direct pairing between B and C. Just because B and C are paired and A and B are paired, it does not mean that A and C can be directly communicated with each other. That means there is no transitive pairing is available when it comes to VPC pairing. All right, so this is about basic terminology on the VPC and typical VPC diagram, how it looks like, and mandatory components, and there are some optional components we covered here, and we also talked about when to use those optional components. Then, so till now we have talked about EC2 in the last sessions, where we have created our EC2 instances. But as you see, let me go to the, let's say, one EC2 instance. Let me launch an EC2 instance here, because I want to show you some presettings which are available here. So whenever we launch any EC2 instance, it asks three details about the network. As you see, it is asking VPC details, which VPC you want to place your EC2 instance into. But so far we have not created any VPC, but still we have a VPC created for you, right? And also you have some subnets also created for you. So whenever you create any account in AWS, you will be created one VPC per region by default, and also there will be subnets created by default, and all the required internet gateway and routing table and access control list. All these things will be created already for you, but they are all default, and by default they will provide access to everybody and every port. So that is one reason why you can't be using the default VPC, because that ACL is not so secured. Let me show you my um, I will not use this. I will not create this EC2 for now. Just I wanted to show you this. This is how every EC2 instance we create requires the network details, that is VPC. That is what I wanted to show you. But let me show you by default what all my how is my default VPC look like. So I am in my VPC section. So I see for my right now I am in Oregon region. So I have one VPC defined here. But if I click on show all regions, so for every region there is a one VPC default VPC created for me already. So let me click on my VPC. So this is how my VPC look like. So I talked about CIDR block, right? So this is how my CIDR block is associated with it. I have my CIDR block is 172.31.00 and 16, and then and also I have this is my default VPC and it says yes, right? So you can also check your account. If you have an account, you can go to your VPC section service and you can look for that. So going back to that VPC dashboard here, I have subnets like I mentioned in this particular region. I have four subnets because in Oregon region we have four availability zones. So for each availability zone there will be one subnet. As you can see here, in this region we have four availability zones. For each availability zone we have they have created one subnet for me, but all are public. Okay, so going back to the there is an internet gateway, which I was telling. There is an internet gateway also created for me, and there is a route table created for me, and there is a network access list also created for me. So let's see and as you see, it will be one for each region. So let me open this network access list. Like I mentioned, network access list is a kind of a firewall. As you can see, the inbound rules here. So it says allow the traffic for all the ports and all the IP addresses here, right? So this is also created for me, and let me show you the route table. So in the route table, you see all my CIDR block is defined here, but I will talk about this more. But all my subnets are attached to the route table. As I mentioned, every subnet should have one route table. So in this case, when I create my AWS account, they created the subnets and they created the route table and they have added all the subnets into that particular route table. So this is what they made sure that a default VPC available for you when you have your account created. So in all these sessions previously when we are creating our EC2 instances, so those EC2 instances are being created in this my default VPC. Okay. So let me go back to VPC to see what else I can talk about. All right. Yeah. So and also security groups. There is some security group also they created. That is what default VPC security group, and in which they would have provided all traffic, all ports, right? so which is not recommended because if you use this security group for your corporate application, anybody can come and uh, I mean, it's a security risk, right? IT people can explain better than me, but it is not safe. So that is one reason why we need to have our own VPC created for any of our application deployment. So, like I mentioned, your default VPC is created with this particular IPD CIDR block. You have this guy here. That's the reason I see if I go to my VPC, I have a IP address something like this. So which allows you to have 65,000 plus 65 plus thousand IP addresses. You can have it. Then the subnets will be divided by 20, which means you can have up to 4,000 IP addresses. Then you have internet gateway created already one for you, and then you have security group and ACL access control list for you. One. Okay. So, like I mentioned, you have the default one, which will have is not secure, which will have access for everybody, and even the security group also has access for everything. So, better not to use the default one. You create your own VPC, which we will talk about now in this session. But yeah, so for creating the VPC, so having such that we have a default VPC and we have enough reasons why we should not use our default VPC. So let's go to the creating our own VPC. So let us plan to create our own VPC. So what Amazon says is we can use one of these three private addresses for our CADR block when we create our own VPC. So whenever you create a VPC, you have to provide a CADR block. So we can use one of these three listed here as per the Amazon AWS documentation, right? And you can say, example, you can create a VPC with a CIDR block with this, which will have provision of having 256 IP addresses. Then you can break that into two pieces, like two subnets with 128 IP addresses each. That means you are breaking like 25. You will have this IP address range. So there is one website you can, if you are already aware, you can ignore it, but there is one utility you can type in here. Like if I type like 00024, which will tell me how many IP addresses I will get and what is the first IP address and what is the last IP address and total thing, right? If I divide with this 5, it will say I can get 128 IP addresses with this, right? So this is how you can plan your VPC. So understand CIDR better so that you know you can better understanding your list of IP addresses available for you. Then you can split your VPC into multiple availabilities, I mean the subnets, and allocate the appropriate CIDR block for that so that you won't be wasting the IP addresses within the subnet. All right. Then subnet sizing. Whenever you get create a subnet, usually let's say you have created a subnet using like this by 25, which means you have 128 IP addresses. Within that, what AWS keeps is AWS reserves some 5 IP addresses for their own purpose. Like very first IP address, they use it for the network address. Then they use it for the router one, and the second they use it for DNS server, and 3 they're not using currently, but they just keep it for the future use. And then broadcasting, they are blocking it so that you will not have your broadcasting feature enabled. So you have to keep that in mind whenever you get your CIDR block defined for your subnet. You have to subtract with the number 5 because this 5 will be used already reserved by AWS. All right, and this is about some characteristics about IPv4 and IPv6 within the VPC context. So you can go through about it. But this is again mostly about CIDR block and reserved IP addresses. You can go through it offline, but I will straight away go to the lab where we create our own VPC. I think we have 15 more minutes, so that's why I am running into creating the VPC. Then we talk about security group versus ACL. Then there will be 2 or 3 more sessions where we will have to talk many other features about VPC. But for now, let me start with creating our own VPC. So I try to document this steps here. Maybe you can also create after this lab. So let me go to the VPC service. So I am creating. So here it is asking about IP CIDR block. For creating a VPC, you need to have your CIDR block mentioned here, so that it knows which CIDR block. That means how many address we have for the my VPC. But this is a wizard, which most of the times, like I mentioned in the use cases, you will have wizards. But I would like to go with the traditional VPC, which will have only few details, and which is what you need because you will understand the internal details of it. So I don't want to go with the VPC launch wizard. Rather, I will go with the classical way of creating a VPC. So for that, you can go here and you just say create VPC. So which means you know only the mandatory things which you need to provide or will be asked here. But as you saw in the earlier, there are some wizards which will help you to create VPCs suitable for your particular use case. Here I am naming my VPC as my VPC, and here I have to provide my CIDR block. CIDR block here, let's say in this case, I am planning for this guy. So let's see on the CIDR block, if I put 16, I'm calculating, I'm getting 65,000 IP addresses, right? Then tenancy, you keep it as default. You can have a dedicated one, but it is going to cost a lot of money for you. So I have my VPC created. Let me go back to the slide. When you create a VPC, it will automatically create an access control list and a route table and a default security group for you automatically that you can verify here. So there is a route table created for me. This is for the VPC which I have. You see here, VPC is my VPC listed here, and access control list. So here I have my access control list created, and then there is a security group which is created. You can verify it or you can ignore it, but yeah, there is one created for your VPC as well. Okay. So this is the first one where you have a security group. So this will be associated with it. Then I am creating a subnet here. So going to subnet, I'm going to create a subnet. So subnet is like, I can name this as a public subnet. So where typically we keep our web components here, and it will ask you, it's a mandatory, as you know, in any form it says it's a mandatory thing. You can, it will ask you to select in which VPC you have to create your subnet. So I have selected my VPC which I created. As soon as I selected my VPC, it immediately showed the CIDR block available, which means you have to now provide the CIDR block which have to be used for my this particular subnet. Like I planned here, I will be using 1.0. So let me go back here and see how many address I get it. So here in this subnet, I can have up to 256, which means -5. That means 251 IP addresses I can use it in my subnet. So I am using that. So I created my subnet. Okay. So I will create one more for my private. So again, I am creating my VPC here, subnet. I'm using 2. So I have 2 subnets created and my VPC created, and have my internet gateway, and I have my route table. So if you go back to this slide, back here, so we have created route table. Route table, anyway, we will have to modify it, but we have created 2 subnets. We have created VPC and we have internet gateway, which is not created yet. We will create now. So that is my next step. Let me go back to it. I have created till here and then attach internet gateway to the VPC. So here I am creating my internet gateway. So as you see, my internet gateway is created, but it is not attached with any VPC. So let me select that. I have selected my new gateway, internet gateway, and it will give me an option to attach to VPC. So here I can select my VPC here, attach. So it is attached. So going back to the steps, and then we have to, as I told, uh, let me go to the route table, which is created here. So this is my route table. As you see, both the subnets which are provided, created already within this route table. But if I see the routes, it also says within the VPC CADR block, say you create 100 more subnets, all the subnets can talk to each other. That is what this route says for. But there is no route to the outside of this VPC. That is what we are going to do now. So that means I will create a new route table. It says my public route table, and route table as requires a VPC. So I am selecting my VPC. So this is to keep my public subnet in this route table. So I have created a public route table here, and then by default, since I have selected my VPC, it has added a route rule to communicate within the VPC, entire VPC. Then I am also adding a new route which says that all IPv4 traffic can talk to my in this public subnet. So this is how you create a publicly routable route table. Then you will be assigning your public subnet to this route table. So I am selecting my public subnet into this, which means right now in my public route table, I have public subnet, okay, which is listed here. And in my default route table, I have only the private subnet, which means this all the EC2 instances I create within this private subnet will not have access to the internet, but they can talk to other EC2 instances that are defined within the VPC. Okay. And this is how we made, I'm just repeating, this is how we made a public subnet. Basically, we created a new route table, and then we have added a new route, basically for IPv4 traffic. But if you say you want IPv6 traffic also, you can do like this, and you can again select the internet gateway and select your gateway, which means your IPv6 traffic also can be communicated with this particular subnet, and you have associated your public subnet here. So let me go back to my steps. What I did is here, I configured a route table. Default route table is always route within the subnet, which I talked about. Then I created a new route table and configured the routes, and I have associated my public subnet into this particular VPC. So what I will do is, I think just for doing the time check, as we are 8:55, I keep this VPC as it is, what we have created now. In the next session, what I will do is, I will create a couple of EC2 instances. One, I will add it in the public subnet, and another I will add it in the private subnet. I will show you that private subnet will not have access to internet, and I will not be able to connect it. Then I will also attach a NAT gateway, which will allow me to install something on the private subnet. I will install some database like a Postgres or a MySQL. Then I will show you how the communication is. That will basically give us some end-to-end kind of knowledge for how VPC can be used. I have to stop the session for this now because I just try to cover what I plan to cover, but I take 2 more minutes to cover the last slide which I have, where I talk about the difference between the security group and ACL. Basically, the both are used for controlling the access of your AWS resources or EC2 instances from the external world, right? Security group basically is associated with the IAM session, which we talked about, the very session number 2, where we talked about security groups. Whenever you create any EC2 instance, you will have to provide a security group on which you will be specifying the ports, which ports needs to be opened for the particular EC2 instance. And as you note that security group is like a stateful. Like if you open a HTTP port 8080, which means it is both inbound and outbound. And also in the security group, you cannot restrict or deny access to a particular port or a particular IP address. But whereas in ACL, you can do that. You can put a particular IP address and you can mention a particular port, and you can say deny the access. So that level of control, granular level control we have with the network access control list. And also you have to specify both inbound rule and outbound rule. Like if you look at the access control list here, which I have, let me select a particular access. You have inbound rule and outbound rule. You have to specify both the things. But whereas if I go to my security group, so it has inbound rule but outbound rule, but it is like a stateful. Like you add one rule here, it applies to both inbound and outbound. Okay, so that is one difference. And the security group has to be assigned explicitly to the instance, but whereas ACL is associated with the subnet, right? And stateful part I covered, and you cannot deny any traffic, which I talked about. And one more important thing with respect to the access ACL is, let me show you that here. So as there are multiple rules, right? Suppose say you want to deny this all traffic to a particular, you want to block a particular uh, IP address. Okay, so you will have to add a rule like this, and you will say all traffic, and then you will be specifying 10.0.1. Suppose say this particular IP address you want to deny the traffic. Okay, so I think for some reason I'll have to check it, but what you can do is you say you want to deny a particular IP address access. So you have to mention like this, and very important thing is you have to remember the rule number here. The rule number has to be less, because as you see here on the network access list, it will be evaluated based on the number. So all the numbers based on the number priority. So in case if you add a rule with 101 and then deny, that is not going to work, because you have already specified allow the traffic to every IP address here, and any subsequently you put any rule to deny, it is not going to work. So all your deny rules should be less than 100 here. Similarly, you are trying to put another rule to allow HTTP access to all here, and any denial rule should be before that. So that's the reason whenever you particularly putting a particular port, it has to be implemented with 100, so that you will have 99 options to block any particular IP addresses or any particular rules. So always deny rules should come first, then allow rules should follow the deny rules. So that is one important thing you need to understand. But I will anyway, and I will show you in the next session how this particular thing come into picture. We will keep as you do the database server, we will be adding those rules here. That time I will demonstrate that. Okay, so yeah, I am done with my stuff. So any questions I can take, or if not, we will meet in the next session. So I am unmuting all. Okay.
So is the content same for all the roles?
Content, which one are talking about ACL?
The course content?
Sorry, course content?
Like all the topics that are listed, does it covers all the roles, or are we pointing to a specific role in the AWS?
Okay, so yeah, that is an important thing. So right now, what we are covering is the very core fundamental AWS services, which I keep telling. I mean, irrespective of the role you are doing, like you being a DevOps or a developer or a technical associate, the core services what we have, you need to have a good idea, right? Suppose say you are doing a DevOps. I know people talk about Kubernetes or ACS or anything like that, but you should have a very solid understanding on the underlying services that build that service, right? That is VPC and EC2. So far what we are covering, I think people may say no, but I think it is applicable for all the roles. because you name any. Let me go to the console here. You see many of the services what you're seeing here, they are built on top of either EC2 or VPC. So IAM to VPC, I would say, are very core. Everybody should have a good understanding with. Most of the times we see problems, right? I have a problem, or only because we don't focus on the fundamental thing. We just learn the tool at a ACS, EKS level or ECS level, but we don't understand the underlying VPC involved in it or underlying EC2 involved in it. We don't understand those security rules or ACL. That is where we get the problem. So I feel we put more time now to understand the fundamentals, so we can save those time on the troubleshooting part. Yeah, to answer your question, yes, it is for
Yes,
all
yes.
roles.
Yeah. Yeah, that's good. Actually, like I just wanted to ask that. Yeah, that's good to have the knowledge on all the things.
Any other question?
Can we get access to the last session?
Sorry, could you repeat?
Yeah. I'm Shweta here, Hari. So can we get access to the last session of EC2 instance and the IAM services?
Yeah, I have provided to everybody who has created the survey. So I hope you have completed, right?
Yeah. I did complete the survey, but